This is part 2 of the video notes for the guided notes that go with growth and decay exponential function growth problems. So what we're going to look at in today's 2 examples is this second formula right here. Now, before we jump into this, we need to make sure we understand the concept called compounding. Okay? Now, compound means a little bit different than what you think about in science or chemistry, okay? In these types of problem, compound means that your rate of change is split up into pieces. Okay, so let's think about what I mean by this. Let's say you go and you have an investment, okay, and you ask about the rate of the investment. What is my percentage rate? You're told that it is 12%, okay? Now, you can get this done in several ways at the bank, okay? The most simple thing is you get 12% per year, okay? And sometimes this is referred to as simple interest, okay? So you put your money in the bank, you leave it there for 365 days for one exact year. And if you don't mess with it, they'll look at it and they'll say, whatever 12% of it is, that's what we'll pay you for keeping it. Okay. That doesn't happen very often. Okay. There are some other options, which is called compounded. Okay. So we have some options. We could say it's compounded monthly. We could say that it is compounded quarterly. Those are the most two popular, but sometimes they might say that it's compounded semi-annually. Okay, now what do those three mean? Well, compounded monthly means at the end of every month in that year, at the end of every month in that year, they're going to stop and they're going to pay you interest. Now, here's the catch. They're going to pay you interest. I'm going to switch cars so you can see this. Each month, okay? But they're not going to pay you 12% each month. What they're going to do is they're going to take that 12% and divide it by 12 months. So at the end of each month, what you basically are going to get is 1%. Okay? If it's compounded quarterly, when we talk about a quarter, we think about 1/4. So that's 1/4 of a year. So quarterly means once every 3 months, because 12 months divided by 4 is quarterly, it's quartered up, is 3 months. Okay. So what's going to happen here is at the end of each quarter, it's going to take that 12% and divide it by 4, and it's going to give you 3%. Okay. Now, semi-annual means twice a year or every 6 months. Inside this, every so you can see it. Every 6 months. Twice a year. So if it's semi-annually, because that means half a year, they're going to take that 12% and divide it by 2, and it's going to give you 6%. Well, somebody's going to say, well, wait, isn't that really the same thing? No, it's not. Okay. Now I want to show you something. And we'll kind of get started with it and see if we can do this. Let's say you start off with $100. Okay. You're going to start off with $100 and we want to invest this $100, but we have some options. What if we wanted to look at it monthly, quarterly, or semi-annually? Okay. Now, what's going to happen at the end of month one? Now, wait, month one says we're going to give it what? 1%. So what you're going to have at the end of month one is this. $100 plus $1, because $1 is 1% of $100. So you got $101. Okay. At month two, it's going to add 1% of the $101. Okay, so what you're going to do is take that $101 you had right here, and you're going to add to it $1.01, because that's 1%. So what you've got is a total of $102.01. Okay. Now, at the end of month three, you're going to take the $102.01 and we're going to add to it 1% of that. So basically what I'm going to add here is $1.02. Okay, because yeah, it's a little bit more, but if I take 1% of that to 2 decimal places, because it's money. So what I'm going to have is $103.01 roughly. Now that's the end of the third month. Okay. Now quarterly means that you're going to get paid every 3 months. So now if you're doing quarterly, they're going to stop right here and they're going to do the same thing. Okay. But quarterly, we get what? 3% of our original amount. Well, our original amount right here was $100 plus 3% of that, which is $3. So what I've got is $103. Now, I want you to look right there. Those totals are pretty close, but they're not exact. Okay. Compounded monthly over a time period is going to give you more money than compounded quarterly. Now, I hadn't even got into semi-annual. If I carried this out to 6 months, I'd have to do 4 months, 5 months, 6 months, and I would compound again right here at 6 months, and I would compound right there at the first of 6 months. Now, 6 months said it was going to give me 6%, so that would be $100 plus $6, which is 6%, for a total of 106. Okay, let's go back over here for a second. Okay, now I'm going to use my calculator right here. If I have $103.01 and I'm going to add to it 1%, my total here is going to be, I'm just using my calculator now, $104.04. If I go for month number 5, it's going to be $105.08. If I add 1% of this to it, That's all I'm doing is finding 1% of my current balance and adding it to it. I'm going to have $106.13. Well, do you notice something? This method also gives me more than that method. Compounded monthly always gives you more money or more interest than quarterly or semi-annual. Okay. And it's based off of the fact that it's stopping and paying you interest more times. Okay. So it's just kind of an overview. You're not going to have a real quiz on that, but that's what's happening. So if they say monthly, you're getting paid every month. If they say quarterly, you're only getting that little extra oomph every 3 months. If it's semi-annual, you're only getting it once every 6 months. And of course, if it's annual, it's only once a year. Okay, so we're going to apply that idea to solve these last 2 examples. Okay, now let's go back to our formula up here though. We have P, which is principal, R, which is rate, N is new for us. N is how many times it is divided up. If it's monthly, N is going to be 12. If it's quarterly, N is going to be 4. If it's semi-annual, N is going to be 2. If it's annual, N is going to be 1. It's how many times in that 1 year that it's divided up. Okay. Now also notice up here, the exponent is not just T anymore, it's T times N. It is how many years times how many times per year that you're splitting it up. So if say like I'm doing it for say getting interest for 3 years, but it's compounded monthly, I'm really going to get paid 36 times. 3 times 12. If I'm doing something for 5 years and it's semi-annual, I do 5 times 2 and say, oh yeah, I'm getting payment back on it at 10 times over 5 years because it's twice a year for 5 years. Okay, so that's where that comes from. So let's look at our example right here. Mary has $2,500 in her savings accounts that pays 2% compounded quarterly. If nothing changes, how much money will she have in 5 years? Okay, so let's think about this. Our P is 2,500. Our R, which is 2%, but that's really 0.02 that we're going to use. Now, it's compounded quarterly. So my N is going to be 4 because quarterly means I'm getting it that year broken up into 4 equal payments. Okay, that's what quarterly means. You just like quartering up a pizza. Okay, now what else do I need? I need my T, and it says how much money will she have in 5 years? So that's a 5. Now let's go to our formula. Our formula is A equals P parentheses 1 plus R. And now watch right here. We're going to divide that R by N. So I'm going to have a fraction right there. Parentheses. And then right here, it's actually T times N. That's not for Tennessee. That's T times N. Now let's put our 4 numbers in our correct spot. P is 2,500. Just like that, parentheses, 1 plus my R, which is 0.02. We're dividing that by 4. Close that parentheses, and up here, I'm going to have 5 times 4. Now, once I do this, y'all, it's just chunk it into the calculator, okay? So 2,500, parentheses, 1 plus 0.02 divided by 4. Close that parentheses, exponent 5 times 4. And I'm going to have, again, round into 2 decimal places because this is money, 2762.24. So in 5 years, she's grown her money to $2,762.24. Okay. Now, pause and copy this down if you need to. And we'll go to our last example. Now, let's take a look right here. Mo is getting 4.5% compounded monthly on a certificate of deposit with a principal of $5,000. How much will he have in 3 years? So guys, same type problem, just worded a little different. Our principal, we're told that is $5,000. Our R, which is 4.5%. But you know, guys, move that decimal over 2 places. So 0.0045. Our N right here, it says it's compounded monthly. So that N would be 12. And it says how much we have after 3 years. So T is 3. Okay, now let's put this into our new little formula. A equals P parentheses 1 plus R divided by N. That's an R right there. Close the parentheses and T times N. So A is equal to 5,000 parentheses 1 plus 0.0045 divided by 12. Close the parentheses, and that's going to be 3 times 12 power. Again, just grabbing my calculator, let's type this in, 5,000 parentheses 1 plus 0.0045 divided by 12. Close that parentheses, and we're going to raise that to the 3 times 12 power. And when I get ready to write this down, y'all, I'm going to make sure that I round to 2 decimal places because, again, it's money to the nearest penny. $5,067.94. Okay. Now, make sure that you've got all these notes copied and into your interactive notebook. After copying these last 2 examples, go to Canvas and find your assignment for more growth problems and work on that assignment.